Good afternoon. I am now on lesson 49, still plane area. I will derive this afternoon the formula for taking the area of a circle with radius r. By using integration, we will derive the formula. Okay, this is the derivation of the formula for the area of a circle with radius r. Okay, let's proceed with the solution. I will read the problem. Derive by integration the formula for the area of a circle if the radius of that circle is radius r, designated by small letter r. Okay, let's bring out the solution. We must have to figure out first the circle on the Cartesian coordinate system. So if we try to bring out the figure, this is the y-axis, this is the x-axis, this is supposed to be the circle, okay? This is the origin, 0, 0, so this length here is the radius, this is the radius, and still the radius, this is still the radius. It's a symmetrical figure, okay, in which all the dimensions going around is designated by r, and that is termed radius, okay. Let's bring out the equation for the circle. So this now involves analytic geometry. If you don't know analytic geometry, you cannot solve this problem, okay. The equation of the circle is given by this equation here. I will recall, okay. X square plus y square is equal to r square. If you try to recall your analytic geometry, this is an equation of a circle in which the center is actually at 0, 0, at the origin. And the value of its radius is r. So the equation of the circle here, I will give you, it is x square plus y square is equal to r square. It is the radius of a circle with center at 0, 0, in which the radius is r. Okay? To derive the formula for taking the area using integration, I will give you the vertical slice solution. For the meantime, since the given circle is actually symmetrical with respect to the y and x axis, we will just compute for the meantime the area of 1/4. Okay? So upon taking the area of the 1/4 portion, we will multiply that by 4, and that is the total area of the circle. That is to simplify calculation, okay? So by using vertical slice, the thickness of the vertical slice is dx, okay? And the height of the vertical slice should be y higher minus y lower, okay? By using vertical slice, the height of the vertical slice will be y higher minus y lower times dx. The height of this will be, this is y higher, y lower is on the x-axis, it is y lower. And which y lower is actually 0. Y lower is 0 is actually a straight line. Straight line. Okay? Okay, let's proceed with the solution. The area of the differential strip is actually differential area is equal to y higher minus y lower plus quantity times dx. You assume for the meantime it's a rectangle. So y higher minus y lower times dx. That's the area. Okay? From the equation of the circle, x square plus y square is equal to r square. From this. Because actually, we are solving for the area between this horizontal line and the 1/2 portion of the circle. And since we know the equation of the circle, we could use that one to relate that in terms of y and r. So from this relation here or equation, from the equation x squared plus y squared is equal to r squared, I said a while ago, this is a circle with center at 0, 0 and its radius r. Okay, so simplifying for y squared, or solving rather, y squared will be r squared minus x squared, r squared minus x squared with transpose, okay? Then take the square root of both sides. Okay? Left hand side, this cancels. What remains is y. Right hand side, it is r squared minus x squared raised to the 1/2. Or if I will place now the proper subscript, this y here is actually y higher. So I place the subscript h, meaning y higher. Y higher is r squared minus x squared raised to the 1/2. And y lower is actually 0. This is a straight line, and this is a circle. The equation of this line here is y is equal to 0. This is. And y higher, since we are now given y higher to be r squared minus x squared raised to the 1/2, we will place it back here, so we could derive now the differential area in terms of r and x plus dx. So going back to this, differential area, I will now place the fraction 4. Why 4? We are taking only 1/4 area for the meantime, okay? We are taking only this area here. So later on, to compute for the total area, we will multiply that by 4. We place this 4 on the other side, okay? Differential area over 4 will be equal to y higher is this, minus y lower, which is 0, plus quantity dx. Okay? What will come out? This is 0, just 0. Differential area over 4 will be equal to r squared minus x squared raised to the 1/2 dx. This is now our differential equation. To compute for the area, we are given the differential equation, try to integrate both sides. We got a 4 here, I place it outside, 1/4 the integral of differential area, equal to the integral from 0 to r of the quantity r squared minus x squared raised to the 1/2 dx. Why the value 0 to r? Okay? To cover up the total 1/4 area, x should move from 0 to r. So the lower limit is 0 and the upper limit is r to cover the total 1/4 area. That's why I place it here, 0 to r. Okay? We got a problem here for the meantime. How we integrate this one? We are now through with integral calculus. So by using trigonometric substitution, we pass by that topic, right? We let x squared equal to r squared sine square of theta. For x now will be r sine of theta. If you take the square root of both sides, okay, left hand side will be only x, perfect square, so this is r sine of theta. Taking the differential of both sides because we need dx on the next step. Dx will be equal to r, the differential of sine of theta is cosine of theta differential theta. We are taking the differential. We pass by differential calculus, right? So if we are given x equal to r sine of theta, dx will be r cosine of theta differential theta. R is constant. So it will be r times the differential of sine of theta, which is cosine of theta differential theta. Okay, simplifying, I place it here. This should be the integral from 0 to r squared minus r squared sine square of theta raised to the 1/2 times dx, which is r cosine of theta differential theta. This value here, sorry, my pen is not so good. The value r square minus r square sine square of theta can be written as r square times 1 minus sine square of theta. And this should be r square. We know that cosine square of theta plus sine square of theta equal to 1. Therefore, 1 minus sine square of theta equal to cosine square of theta. So this is actually times cosine square of theta. We will replace the difference 1 minus sine square by cosine square of theta. So what comes out? This will be r square, okay, times cosine square of theta, as from this, raised to the 1/2, times the quantity r cosine of theta differential theta, that is dx. Okay? What's next? The integral from 0 to r. Perfect square, we raise that to the 1/2, so it will be r cosine of theta. Right? Guys? Times r cosine of theta differential theta. R times r is r square, I bring it out. The integral from 0 to r, cosine square of theta differential theta. This is a cosine square angle. And there is an equivalent of cosine square in terms of a double angle, and that is equal to 1/2 times 1 plus cosine of 2 theta. So for this one to be integrable, we replace that one by its equivalent in terms of a double angle. And that is actually 1/2, quantity 1 plus cosine of 2 theta differential theta. Okay? I will continue here, guys. Therefore, the left hand side is actually area over 4 equal to, what's next? This should be r square over 2. We got the 2 here. I bring it out. So r square over 2. This is r square over 2. The integral from 0 to r of the quantity 1 plus cosine of 2 theta differential theta. And this is now integrable. Okay? The first one, the integral of 1 times differential theta is just theta. The integral of cosine of twice theta, u is twice theta. du will be equal to twice differential theta. So actually, we are missing 2 inside. Okay, so there should be times 2 here, so we place 1/2 outside. So the integral will now be 1/2 sine of 2 theta. The integral of cosine of twice theta is sine of 2 theta. Okay, with the limit from 0 to r. Okay, to place the limit, we replace theta in terms of x because 0 and r are actually abscissas. It's not an angle. Okay, and theta is actually arcsine of x over 4. It came from this. It is from this. You got it, guys? Okay, I will show you. Because from the original substitution, x is equal to r sine, sorry for this one, sine of theta. Right? Therefore, sine of theta will be equal to x over r. Therefore, theta equal to arcsine of x over r. That's it. Okay? So, the resulting integration will be r square over 2 arcsine of x over r plus 1/2 sine the total angle will be twice of arc sine of x over r with the limit from 0 to r. Okay? If we place the upper limit, what will come out will be arc sine of r over r, okay, plus 1/2. I will put the simplification here, over here. 1/2 sine, the total angle is twice arc sine of r over r. Okay, that's the upper limit. We repeat this one by replacing this r here by 0. But since this is sine, okay, and this is sine, what will come out for the lower limit will be 0 plus 0. Okay, so actually the lower limit got nothing to do with the final answer now. So because it is 0, okay. So what will come out? This should be equal to r square over 2. This is area over 4 times the quantity. R over r is 1, okay? And what is the angle whose sine is 1? It is 90 degrees. It is 90 degrees. The sine of 90 degrees is 1. So actually this will become pi over 2. It seems arc sine of 1 is actually an angle. And the angle whose sine value is 1 is actually 9 over 2. Pi over 2, or actually, this is actually 90 degrees. Sine of 90 degrees is 1. Plus 1/2 this is 90 degrees, right? 2 times 90 degrees is 180. So it seems in here, we are taking the sine of 180 degrees. Sine of 180, it's a horizontal line. This is actually 0. Okay? Right? 0. So this is now 0. This is times 0. Therefore, area over 4 equal to r square over 2 multiplied by pi over 2. This is now 0. Okay? Area over 4 now equal to pi r square over 4. And multiply all terms by 4. This term cancel with this term cancel with this. So the final answer will be pi r square. So the formula for taking the area of a circle is pi r square. So the formula we are using under lower mathematics, in which if we are given a circle with radius r, to take the area of that, we will just take the value of pi, then we square that radius, and that will be the total area of the circle. If this is r, the total area will be pi r square. That's it, guys. That's the derivation of the formula for taking the area of a circle if the radius of that circle is radius r. So this is actually a general formula. Okay, good afternoon, Los Angeles.